All right, today we're going to look at the area of trapezoids, rhombus, and kites. Rhombi and kites are actually going to have the exact same formula, so we kind of put them in the same category, and then trapezoids will be a little bit different. So I've drawn you two different types of trapezoids here because, again, we can see it two different ways. One type of trapezoid, we already have the right angle. That's always nice. Okay, if we have the right angle, then the height is already going to be perpendicular to your two bases. Okay, otherwise, if not, you've got your two bases, you may have to draw in the height on the inside. We'll look at that as well today with that. Okay, so area of a trapezoid, the formula we're going to use is going to be 1/2 height and then base 1 plus base 2. Because the bases are the same, okay, that we have to add them. And basically, we're doing the average of the bases times the height. They're just kind of in a little bit different order for us when we're working with them. All right, so let's go ahead and jump right into working with our trapezoids. All right, so you'll notice for this one, they actually give you everything you need. Okay, they give you the two bases, which are always the two parallel ones. Remember, trapezoids always have two parallel sides. Okay, and then you have the height that you're working with that is perpendicular to your bases. Again, if it's perpendicular to one, it's going to be perpendicular to the other with the trapezoid. Okay, so area then, this one we can just fill in our information. So area is equal to 1/2 height, which is 3, and then base 1 plus base 2. Okay, when you are putting it in the Google form, you don't need the A equals, but you should have those pieces. Okay, put each of the pieces in separately so I can make sure you understand what you are working with when you put your equations in. Okay, so for this one then, if you go ahead, you'll end up with 21 yards squared. Okay, these ones you'll notice just ask for area. They don't ask for perimeter, so we don't have to worry about it. Just read the directions. Sometimes you need to give perimeter, sometimes you do not. Okay, it just kind of depends on the page and that type of stuff. They kind of mix it up so you don't do it all the time, but you will do it some of the time. This is a really important one for us to look at because this one is an isosceles trapezoid. Remember, isosceles trapezoid means that your two legs are congruent to each other. Okay, we're going to be working with these quite a bit, and we need to make sure we know how to work with them correctly. Okay, when you work with an isosceles trapezoid, a lot of the time, okay, you will have to put the height on both sides. Now, the reason I put the height on both sides is it's going to help me find this little piece down here. If I only do it on one side, I don't create that rectangle in the middle that I need. Okay, because if I deal with this rectangle, if that's 18, that tells me this middle part's 18. Okay, well 30 minus 18 tells me I have 12 left over. And if it's isosceles, that 12 is going to get split equally into 6 and 6. If it's not isosceles, then it will not get split equally. Okay, but a lot of the ones we work with will be isosceles. Okay, so just make sure you recognize that. Okay, now that's going to help me find my height. Doesn't matter if you want to find it on this side or this side, you can do it either side. Okay, but I'm going to use the Pythagorean theorem. I've got x squared plus 6 squared equals 20 squared. Okay, if you go through and simplify that, you'll end up getting 2 square root of 91 for your height. Again, I made it kind of something that doesn't work out wonderfully because I want to talk about that with you. Okay, so our area then is going to be 1/2 your height, which is what we just found, the 2 square root of 91. And then it's going to be 18. Make sure you do the whole base, which is 30. Now again, don't put the square root in the calculator. We are not rounding. We are keeping things as exact. Okay, so you would take 1/2 times 2 times 18 plus 30. Make sure you don't do 18 times 30. Sometimes kids will do that every once in a while. Okay, and what you'll end up with is 48, and then we'll just attach the square root to it. and that would have a label of meters squared. Okay, so again, do not put the square root in the calculator, and just be careful when you put it in the calculator that it's 18 plus 30, not 18 times 30. Okay, so again, with isosceles, a lot of times you're going to have to put the height on both sides. Okay, the next one's not isosceles, but we're also going to put the height on both sides. Okay, anytime you're missing that height, you're probably going to put it on both sides. Okay, so this one gives us 16, 12, and it gives us a couple angles. It tells us this one's 120 and this one is 30, okay, which actually really helps us out with this problem. Okay, so I'm going to draw in the height on both sides. Okay, what I have over here is I have a 30, 60, 90 I'm going to work with. Okay, right now the 12 is the hypotenuse. So if 12 is my hypotenuse, that means my short side has to be 6 because I divide by 2. And my long side has to be 6 square root of 3. Again, you need to look back at that and make sure you have that down if you have forgotten that. Okay, if this is 16, then this middle part's going to be 16 because that's a rectangle. If this is 6 because they're both heights, so they'd have to be the same in my rectangle. And then what happens here is it works out pretty nicely. Because I have a 90 here, that means it has to be 90 on this side as well, which tells me this top angle is 30 and the bottom angle is 60. So I end up with another 30, 60, 90. Okay, this time 6 is the long side, so I'd want to divide by the square root of 3 to get my short side. And when you simplify that, you'll get 2 square root of 3. Which then makes the hypotenuse 4 square root of 3. Okay, so this one used a lot of 30, 60, 90. And again, a lot of your problems will. Okay, that can't come as a surprise to you. Okay, so now we have everything we need. So it's going to be 1/2 the height. The height is the 6. And base 1 plus base 2. So base 1 is 16. Now, base 2, again, I did this on purpose so we could talk about this. I have the 16 there. And then I have 2 square root of 3 and 6 square root of 3. Okay, we can add them because they have the same square root. But when you add them, remember, do not change the square root. We just add the coefficients. Okay, just add those numbers on the outside. Okay, so then we want to simplify this. Again, do not put that guy in with the rest. Okay, for this one, we almost have to do it in a couple different parts. Okay, so I would take 1/2 times 6, which is 3. 16 and 16 is 32. And then I would distribute the 3 to both of those. And when you distribute the 3, you'll end up with 96 plus 24 square root of 3. Sorry, handwriting got a little messy there towards the bottom. Okay, so again, being able to simplify and do the algebra part is very, very important, as well as being able to do the other part. All right? So the last thing we have then is to deal with the rhombus and the kite. And rhombus and kite, again, will have the exact same formula as we go through these. Okay, so whether it's a rhombus, which remember, a rhombus has all 4 sides congruent, or it's a kite, which that means 2 and 2 are congruent, we use the same formula. And the reason we use the same formula is because it has to do with the diagonals. And the diagonals in both of these are perpendicular to each other. Okay, so anytime you have perpendicular diagonals like this, you use this formula. Okay, and the formula for both of these is going to be area is 1/2 diagonal 1 times diagonal 2. Doesn't matter which diagonal's 1, which one's 2. You're basically just multiplying the diagonals and taking half of it. Okay, and again, it'll be the same formula for both the rhombus and the kite.